So today I'd like to talk to you about geometric sequences. So we have two main types of sequences in mathematics that we discuss in your curriculum. One is arithmetic sequences and one is geometric sequences. So the arithmetic sequences are ones which go plus, 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 so where you're always adding the same value to your sequence. And geometric sequences are ones where you multiply the previous number by a ratio, which is going to be constant. So for example, in all three of these sequences, I've chosen the same ratio so that you try and understand how we name sequences. So this video is all about naming sequences. So if you notice, to go from 2 to 6, I've multiplied by 3. To go from 6 to 18, I've also multiplied by 3. And to go from 18 to 54, I've also multiplied by 3. So this sequence is a times 3 kind of sequence. And so is the second one. 3 to 9 is times 3. 9 to 27 is times 3. 27 to 81 is times 3. And then this one is the same. 5 to 15 is a times 3 sequence. 15 to 45 and 45 to 135. So all of these sequences have the same ratio. The ratio is equal to 3, which means that I multiply a previous term to the next term each time by timesing by 3 or multiplying by 3. So the way that you can prove that is you can take the second term divided by the first term to see that that's true. So you should do, for example, 6 divided by 2 and show that that is 3, or 18 divided by 6 and show that that's 3. So in maths we say un plus 1 divided by un, the next term divided by the previous term, and that's usually going to be equal to the ratio for geometric sequences. Okay, so this is how we can find the ratio each time. Now, that's only the beginning, because your skill is going to have to be to name the sequence so that you can find any term. So that if you wanted to find the 7th term, it wouldn't be too difficult. So how do we name the sequence? Well, here's a little thing that I like to do, and that might help you. Let's talk about un first. So for un, I'm going to say un equals 3 to the power n minus 1. And then I'm going to multiply that by the starting point, and the starting point is 2. So times 2. Now let's see how that works out for us. So this is for n greater than or equal to 1. So n is a whole number, which is going to take the values 1, 2, 3, 4, 5. It's just going to start at 1 and move in ones. Okay, so for the n value 1, you're going to get 3 to the power 0, and 3 to the power 0 is 1, times 2. Which is going to give you 2. So u1 equals 3 to the power 0 times 2, which is 2. u2 equals 3 to the power 1 times 2. So 3 to the power 1 because you do 2 minus 1. Right, u2, remember u2, so n is 2, 2 minus 1. So 3 to the power 1 times 2, which is 6. u3 is going to be 3 squared times 2, which is 9 times 2, which is 18. So you see how I'm generating u1, u2, u3, and then u4 is going to be 3 cubed, so 27. 27 times 2 is 54. So this formula works well for un. Now let's talk about vn here. So vn is also a 3 to the power n minus 1 sequence. So we can say vn equals 3 to the power n minus 1, and then times the starting point, which is 3, so times 3, I could say that. Or I could just call it 3 to the power n in this case, because that's what the sequence is, okay? For this one, I could say it's 3 to the power n minus 1, so Zn equals 3 to the power n minus 1. And then my starting point, my first value is 5. So 3 to the n minus 1 times 5. And that's what you do. This is how you call the sequence the ratio to the power n minus 1 multiplied by the starting point. This is what you do every time. So if you needed a general formula for this, just to make sure that you understand how to do these, this would be your general formula. You would say a sequence un, which is geometric, should be the ratio to the power n minus 1 times the starting point, which is what we call the first term. So this is your ratio here. And this works for all geometric sequences, and this is the first term. Okay, so the ratio to the power n minus 1, as long as n is greater than or equal to 1, and this is the first term. So that you can find any of the terms that you need to. So if you wanted to find u7, you could say it's 3 to the power 6 times 2. It would be 729 times 2 for this sequence. And you just need to plug that into your calculator and figure out how much it is, or calculate it by hand if you'd like to. Okay, so this is geometric sequences part 1. The next section of geometric sequences is going to focus on convergence and divergence. So when sequences go off to infinity, or when they have an upper bound, and we'll look at how to add them together, which is the sum of a sequence formula. If naming geometric sequences was useful to you, well, first of all, make sure that you practice a little bit so that you're able to name them easily. Remember, ratio to the n minus 1 times the starting point. That's all you need to do. Not too difficult. That's your general formula right here. And practice a little bit. You can follow us on YouTube. You can like our channel and subscribe to make sure that you keep up with us and that you follow the short math lesson format that I'm putting out all the time to help you guys. You can also follow us on Instagram at MathemagicMD, and if you'd like to see us on Facebook, we're at facebook.com/HLMathemagic. And remember, geometric series are easy as long as you know how to express the formula. All right, thank you so much. See you next time.